This is the single phase grid tied inverters. So this is the T type of inverters where we are using the 6 switches. You can see 1, 2, 3, 4, 5 and 6 switches, and this red one will be the fast recovery diodes will be there, so that is placed with the switches, and the white one will be the gate drivers. You can see TLP 350, the 1, 2, 3, 4, 5 and 6 gate drivers for the 6 switches will be there, and these are the relays which is connected at the output of the grid where we are controlling the inverters and the grid side, the interconnections, and these are the microcontroller boards through which the gating pulses we are supplying it to the inverters, and this is the DC link capacitors, and this is the boost part. This is the boost part. So the boost converters, because the DC in case of single phase low power wattage, we are boosting the voltage from 60 volt to 360 volt, and from 360 volt it is integrating with the grid. So now you can see the status of the relay. Actually only 2 LEDs are glow, that means the relays are not connected. Whenever we will give the pulses, then the relay will operate. Now in order to operate these optocouplers, we required the power supplies. The power supplies generally previously we used to design it through this type of converters, where the transformers we are using it, so 230 volt to 12 volt, and from 12 volt we are rectifying that to the 230 volt to 12 volt RMS, and from 12 volt RMS AC we are converting that to the DC, and we are getting the output from this one. So here also you can see 1, 2, 3, 4 and 5 switches, 5 supplies are there. Later we have replaced this power supply because this is bulky in natures, because in these cases the 5 transformers are required, and even the so many circuits are required, so the circuit is very big. So in order to do that, in order to replace that with the smaller circuits, we have designed a flyback converters. Now you can see this is the small flyback converter. This is also in house, we have designed it from the scratch, each and everything, so which is having a power capability so that it can drive the 5 switches. You can see here 1, 2, 3, 4 and 5. So this is the multi-winding flyback converters actually. So here we are deriving the 24 volt supply. So from here to here you can see, so here to here we are getting 15 volt. Now you can see 15 volt, and the negative supply also we are giving it. So you can see the negative supply. You can see the negative supply of -9 volt for every switches. In order to do the fast turn on and turn off, we are using a 15 volt plus supply and -9 volt of the negative supply, because we are using the IGBT. So IGBT actually it requires the negative supply to turn off also. Similarly, we have designed the 5 flyback converter for the 5 switches, for the 6 switches, because 2 lower switches will share the common supply, as you can see this one. So this is having the higher power rating windings. So here the 5 supplies will be there for the switches, for these all 6 switches, and the boost converter switches, and this is the another flyback actually, which we have designed it for the relay and the display cards actually. So here the output of this one, it is going to the relay, as you can see here. So this is the input actually, we are giving it from the supply, from this battery emulators actually. So this is the complete supply we are giving it from this one, and that output it is connecting to the grid. And in the DSO we are showing the grid injected current. So now you can see that the flyback actually, so this flyback is having a capability so that the input voltage variation range can be from 60 volt to 400 volt. So directly we can connect with the DC supply with 400 volt or 360 volt also, or from the 60 volt also. So it will start initiating from 60 volt, it starts giving the power that plus 15 and -9 volt to the gate driver, so the gate drivers will operate. Now we will start the inverters by giving the 370 volt as the input, and we will show you the current waveform that is sinusoidal in nature, which is feeding to the grid. Now we have not given any gating pulses actually. So now we are initiating the controllers, and now you can see this is the power supply actually, through which we are initiating it. Now you can see, now we have initiated, and the current which is feeding to the load, you can see it's perfectly sinusoidal in nature. So this right now we are operating with 4 kilowatt of the capability. This is having a capability, it can go up to 5 kilowatt. Now you can see this is the thermal imaging camera, and we are monitoring the temperatures also. So how the temperature rise it is happening. And this is the complete grid tied inverters which we have developed in house actually. So each and everything we have discussed by our own. each and everything we have designed in house. Now we are sending it for the complete prototype. So now you can see here the complete, it is filled with complete wires. So now we are going to design each and everything, even the flyback converters, even the display cards, controller card, each and everything will be on the one board. So this is the discrete testings we are doing it, right. Later we will extend this three phase single phase inverter to the three phase by adding one leg, and the complete prototype of the three phase inverters will also be ready by the end of April. And each and everything in this board actually we have designed by our own, and it is working perfectly fine, and we are testing also, we have done it, even the boost converter part also. So the boost converters actually we are giving the pulses from 80 volt or 90 volt, and it is boosting up to 360 or 370 volt, and from 370 volt we are integrating to the record. And this is the controller through which we are giving to the pulses to the switches. Actually this is also in house, we have designed it each and everything. This is not we have purchased it, everything we have designed by our own. And even the complete boost converter testings actually we have done it by placing a heatsink actually. So this is also we have tested for 4 kilowatt, and this can be extended up to 5 kilowatt. So the complete testings with in house actually, that will for three phase inverters, that will be ready by the end of April.